Okay guys, here we go again. We are going to build our tutorial for the intro to React. This is on the reactjs.org. If you remember last time, we did start this a little bit. We didn't do much. All we did was we got React running, and so we went to this site. We read what we were reading. We did setup option number 2, so this is for the local. Not required for the tutorial, but it will help us later on anyways. So we installed the Create React app, created this project called My App, deleted everything from the source folder how it wants, and then added index, and so we did through step 6, which was including this part. Okay, so we ran it, if you remember last time. Let's go ahead, Windows R, CMD, npm, I think we need to go E drive, go to our folders, let's just go this way, tutorials, open up here, and then we can control right click of that's fine. I know where we're going. Tutorials slash needs to be a backslash there. My app. Oh, my bad. Change directory. Don't forget that part. There we go. Now we can go npm start, and if everything works how it should, I think it says it's running. So now we just need to go localhost 3000. Let's see if it brings anything up. It did not. I think it just was taking a little more time than I expected. Because this brought up on its own, and it says it's starting the development server. There we go. That is where we left off at. So we got this back up and running. So let's go ahead, and same thing as before. We'll just follow their instructions for now. If you get stuck, check out the community support resources. Well, hopefully we don't need it, right? So basically, React is declarative, efficient, and flexible JavaScript library for building user interfaces. Okay, so don't let this part confuse you. React is for user interfaces. It's our front end development. It doesn't do the back end for us. It does our front end. So this helps us display everything. So get to the funny XML-like tags soon. We use components to tell React what we want to see on the screen. When our data changes, React will efficiently update and re-render our components. Okay. The render method returns a description of what you want to see on the screen. Okay, does that make sense? No, not yet. Of course it doesn't. Takes the description and displays the result. And we will get into how that does. And this is how it does it. It does a return statement, and you give it elements that you want to have it displayed on the screen. Okay, so let's go inspecting the starter code. If you're going to work on the tutorial in your browser, open the code, blah 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 blah. This starter code is the base of what we're building. They've provided the CSS styling so that we only have to focus on learning React. So again, if you want to go over to Code Academy or the Code Academy freecodecamp.org, that's the other one. Remember both of those if you want to buff up on your CSS or HTML or basic JavaScript even. So, by inspecting the code, we'll notice that we have 3 components. So let's go ahead to the index.js. We have a square. So this is one component. See, it says class square, and it extends a React component. Then we have the board, also extends the React component, and the last one we have is game. So this is what it says it does. The square component renders a single button, and the board renders 9 squares, okay? The game component renders a board with placeholder values which we'll modify later. There are currently no interactive components, okay? But we will make it interactive. So the React has what's called props, short for properties. We're going to pass some data from our board component to the square component, okay? Basically, we are going to do exactly what they want. Change the square's render method to show that value by replacing the slash to do with this.props.value. Okay, so let's go up here. That was inside the square. We see, okay, button right here. Same thing, button, class name, square. We now want to replace it with this dot props dot value, and then we are going to say we need to change all of this. My bad. Let's read it a little bit more carefully. Render square. So that's going to be here. Render square I. We need to return square with a value equals I. And end this with a semicolon. And now change the square's render method to show that value by replacing with this.props.value. So render, as you see right here, we have render, we go down to return, button, class name square, we put this.props.value, and then closed button. We close the parentheses. Now notice this parenthesis goes to this return, and then a semicolon afterwards, okay? And this is all inside this render, which is inside of the class. So render itself is a function, you can call it. I know we didn't declare it as, we didn't have to say function render. For React, all we're doing is saying render, and then we tell it what to render. Okay, so now, before we did anything, oh, it already loaded for us. So let's go here. Before we did anything, we just had this, right? All we had was a blank box. Well, now we have all of this. 0, 1, 2, 3, 4, 5, 6, 7, 8. You may be wondering, well, how did we even figure that out? Well, okay, let's look at this. This is called render square right here, right? That's a function. Where are we passing values in? Well, we return square value I. This goes up to here. This is this square that it returns. Remember, the return says what to display. Because it's a class, we can use it inside of this XML format here. And we say value is I. So that goes to the props value, because we pass in this as a prop. Well, inside this board's render, notice we say return, okay, class name, status, which is going to show this status. We'll get into that a little bit more later, but it goes here. After that, we go to our class name of a board row, okay. Now we're using these class names for our CSS, but right here we say render square. We pass in 0. Look where that goes, 0, right here, 1. Now it goes to this I first, and then it passes to here, onto line 17. From here, now it goes up to class square, and sets I as a prop. Well, I is what's been passed in, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we'll be doing more with this a little bit later, but this is one of the main features of React. You can pass values into different objects as props. So now, let's look at the next part. Our next part is making an interactive component. So instead of filling all the squares with the 0 through 8, let's fill the square component with an X when we click it. So first we need to change the button tag that is returned from the square component's render function to this. Okay, so this is on square. So notice we do all of this inside together, okay? Let's not copy and paste. The reason why, yeah, you can do this. You can totally copy. And you go, okay, that was the return statement, paste. Sorry, got a little cough there. The problem with this, it works. It does work. But do you have any idea what you just wrote? You don't even have to look at this. You can literally just copy and paste exactly like we just did. So let's not do that. Let's actually understand our code, okay? So very first thing, instead of just getting rid of everything, let's go ahead and comment it out. Control and then the /. Inside of our return, we open up, we want a button. Now we have to still give it the class name for the CSS. That's going to equal square, right? From here, here's our function, onClick. This is a normal JavaScript function, onClick. We are going to do a function. And that function that we're going to do, nope, they want it that way. Let's leave it there. Function. And I like putting it on this line. Doesn't really matter, but I think it's a little more readable. Click. Semicolon. Okay, now let's look at everything so far. We have closed. What have we closed? Well, this actually should be a bracket. Sorry. OnClick equals function. So, very first thing, we close the alert. This doesn't have any parameters passed inside it, so let's look at this part. We did close that. You can tell because there's a blue line underneath where it ends at. The next one closes the onClick. So all we need to do at this point is close our button. We've now just closed it. But are we done? No. The reason why we're not done is because we haven't, and what we need to do is put back in this .props.value, because right now if we just close the button, it would render. Let's go ahead and, oh, it doesn't, yep, there we go. And when we click on a button, look at that, we get an alert that comes up that says click. And it definitely works. However, the problem is we're not rendering anything in there. So we need to, right before we close the button, same as before, this .props.value. Remember, it's in these curly braces, and that is just to show what displays in it. Now, if we come look at that, we got it back again, 0, 1, 2, 3, 4, 5, 6, 7, 8. But the nice thing now, when we click on it, we could even probably, haven't tried this out, but let's see what would happen if we do that, huh? This is a reserved word. Yes, it is. It does not like it there. Kind of interesting, because we do the same thing right here, don't we? And the reason why is we'd have to use, I believe, let's try it with ECMAScript. See what happens. It still says it's a reserved word. Let's go ahead and make sure I did that right. ECMAScript 6 arrow function is what it's called, or also called a fat arrow apparently. Syntax arrow curly brackets. Yep, that is correct. We still have everything closing properly. It just doesn't like it. That's okay though. We'll change it back exactly how they want. It was an experiment. We can go into a little bit more of those types of issues later. Just know that even doing that ECMAScript, notice I didn't say function anymore. I just have this and this fat arrow, or arrow function as it's called. This is a new feature of ECMAScript 6. It's been out for a little while now, but we'll still call it a new feature. When and why, and when you shouldn't. Okay, so there are reasons you shouldn't. One of the more popular features of ES6 introduced a new way of writing concise functions. No parameters, single parameter, statements. So right here, if cat is hungry, else do not feed the cat. So there's some cool ways you can do this, right? Object literals. arrow functions are anonymous, which means that they are not named. So first off, they're harder to debug when you get an error, because exact line number, etc. can't necessarily do that. No self-referencing. So a self-reference is when we use this. Speaking of, I wonder, props.value, just for fun. I didn't think it would work. So no binding of this like we do here. A lot of times when you're doing a function call inside of something like this, you have to say this to specify the upper tier. And so with arrow functions, you can kind of keep that a little easier. When you should not. When you call cat.jumps, the number of lives does not decrease. It is because this is not bound to anything and will inherit the value of this from its parent scope. Okay, so lives 9, jumps. If you do this dot lives, subtract 1. Well, this dot lives does not refer, this part does not refer to this lives. It actually tries to refer to lives above it. Oops, sorry. It's trying to refer to lives above this whole thing. So, anyways, there are reasons to use it and not to use it. Go ahead and save this. Notice another cool feature of Node in general, and just failed to compile. It already switches for us. Unexpected token 922. Well, what is that unexpected token? It is curly brackets. I didn't get rid of them. Now when I save, notice I did not even refresh this at all. It automatically did that for me as soon as I saved, and that is because on the back end, when we look at the command prompt, we're running Node behind the scenes. This is our server, you could say, and it automatically senses that save and refreshes and tries to get the new information, which is kind of cool. Okay, next, we completed this, we got through, we closed the button. Now we know this works, so at this point we can get rid of this code. We want to clean up our code as we go along. That way it is easier to maintain later and more readable. So we finished that. Dun, dun, dun. That's all closed. Good. If we click on a square now, we should see the alert in our browser. Yep, we got that. To save typing and avoid the confusing behavior of this, we will use the arrow function syntax for event handlers here and further below. Notice I did the exact same thing. We already did an arrow function. Kind of cool, right? We're passing a function as the onClick prop. So that's why we can't get this, because the function itself is passed as a prop to the square. Anyways, as a next step, we want the square component to remember that it got clicked and fill it with an X mark to remember things. Components use state, okay? So every React component has props and state. can have state by setting this dot state in their constructors. This dot state should be considered as private to a React component that it's defined in. That means that no other React component should be able to find the state of another React component. Okay, it's like their own personal diary or safe or whatever, bank vault. It's for them and them alone. Let's store the current value of the square in this dot state and change it when the square is clicked. Okay, so let's go up. We do not have a constructor right now. Notice we'll add a constructor to the class to initialize the state, so we're still working in the square class. Constructor takes props. Okay, from here we have to call super. Super goes to the React component and we send props to that React component. This dot state equals value colon null. And notice afterwards we need a semicolon. Why do we need a semicolon? Now this is written on 3 lines, but if we take out all the other lines, look at that. It is literally assigning it as a statement or an object. Okay, so we have the actual equal sign. So that this assignment means we need a semicolon at the end of it. Okay, awesome. We're setting it to null. From there, we have render, return, button, class name, on click. That should all be the same. Yep. Okay, good. Now, all we've really done is we've saved props to super and a state with a value inside the state of null at this point. Okay. You need to always call super when defining the constructor of a subclass, always. And all React component classes that have a constructor should start it with a super props call. Okay, so every single React component that has a constructor, you should always do this. So inside the button tag, we're going to replace this .props.value with this .state.value. So right here, we can do that instead. Now, we're going to replace the alert function, okay? We're going to say this .set state. So instead, we're going to get rid of this. Now I'm just erasing it because it's just an alert function. It doesn't really do anything for us anyways. So on click, we want to say this .set state. We set it with our parameters. We're setting or giving a parameter to the function, remember. And then brackets, value, colon, and we're doing this as a string of 1 character. Now notice, kind of interesting, we do not put a semicolon here. The reason why is this all runs together inside of this return. So all of this is one object inside of this return. It's one element, okay? And the way React does this inside the return is you don't use semicolons. So now that we got that, put the class name and on-click props on separate lines for better readability. We can do that, I guess. And then on-click equals, go ahead and get rid of that. And then we can move those there and put that back down there. It's a lot, right? I feel like I have one too many. So let's check this again. So this closes there. Parentheses close the set state. This closes the onClick function. And this closes onClick. Let's look at theirs. That closes. Parentheses close. I have 4. They have 3. That is because we no longer need this bracket. Okay. Now we should be good. This.state.value in button. By calling this.setState from an onClick handler in the squares render method, we tell React to re-render that square whenever its button is clicked. Okay? That's why we said set state. Re-render it. So now, let's go ahead and save everything. Let's go over here. Look, we don't have those numbers in here. Why? Again, remember, we're actually, instead of going this dot props dot value, which was these 0 through 8, we're saying this dot state dot value. Well, before we've clicked the button, the value in the state is null. So there is nothing. But when we click it, look at that, we get an X. Cool. Pretty good. So now let's see what they want us to do next. Okay, completing the game. We now have the basic building blocks for a Tic Tac Toe game. To have a complete game, we now need to alternate placing X's and O's, and we need a way to determine the winner. Right, okay. So currently each square component maintains the game state. To check for a winner, we'll maintain the value of each of the 9 squares in one location. Okay, so we may think that the board should ask each square for the square state. Although the approach is possible in React, we discourage it because the code becomes difficult to understand, susceptible to bugs, and hard to refactor. Instead, the best approach is to store the game state in the parent board component instead of in each square. So, the board component can tell each square what to display by passing a prop, just like we did when we passed a number to each square. Now, that may sound a little confusing, so let's see what they want. Let's take this opportunity to try it out. We'll add a constructor to the board and set the board's initial state to contain an array with 9 nulls. These 9 nulls correspond to the 9 squares. Okay, so now board, we need a constructor. Constructor. Props. Notice it's right here too, if you need it. We then, as they said, super props semicolon. This dot state, so this is the board state, equals, and we're calling it squares, equal colon array of 9, and we're going to fill that array with values of null. Now you don't really need this comma on the end, but it's good practice if we had something else in the state, like test, here I am, something like that. You can do that and separate it with a comma, but you don't need it. For practice purposes, how they have it, we're gonna go ahead and do exactly how they have with this comma. We now have a state. We need to end it with a semicolon because again we're assigning it. So there we have that. When we fill the board in later, the board will look something like this: 0, null, x, 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 0, blah, blah, blah. The board's render square method currently looks like this: square value I. Right here, render square value I. So in the beginning we did pass the prop value down 0 through 8. This is why square currently ignores the value prop passed to it by the board. Now we will now use the prop passing mechanism again. So we're going to pass the prop down to the square from the board. We will modify the board to instruct each individual square about its current value. So very first thing, render square. Okay, well, let's go ahead and remember, we're going to go ahead and comment this out, create a new line, return square value equals this dot state dot squares I. And then we're going to just self-close it. Well, that's kind of interesting, right? Do we think it'll work? Hopefully. Hopefully it'll work. Where are we getting I from? Well, we're getting I from right up here. And then each square will now receive a value prop that will either be XO or null for empty squares. So now we got to go back to the square. So we're up here inside square. Nope, I apologize. We are still on the board. Inside render square, instead of closing this, we need to pass on click equals this dot handle click I. Then we close it. So we'll see in just a second why we did this. And part of it is to maintain the board state's privacy. So we'll pass down a function from the board to the square. This function will get called when a square is clicked, and we'll change the render square method in board to okay. Now we're passing down two props from board to square value and on click. The onClick prop is a function that square can call when clicked. We'll make the following changes to square, so now we finally come back up here. First off, let's see, render, return, button, class name square, onClick. Instead of saying this dot state dot value, now we need one of these, right? Because that closes the onClick. We now say this dot props dot onClick. Now notice where that's coming from. Well, it's coming from here. That we are now sending it not just a value prop, we're also sending it an onClick prop. So this dot props dot onClick. And then we can now rechange this back. This dot props dot value. And the reason why we can change that back, when a square is clicked, the onClick function provided by the board is called. Here's a review of how this is achieved. The onClick prop on the built-in DOM button component tells React to set up a click event listener. When the button is clicked, React will call the onClick event handler that is defined in Square's render method. So we have this onClick event handler inside the render. This event handler calls this .props.onClick. The Square's onClick prop was specified by the board. And since the board passed onClick this .handleClick I to Square, the Square calls this .handleClick I. Easy enough, right? Because we stated it right. Where did it go? Here. When we say onClick here, this .props.onClick, it just calls this .handleClick I. We've not defined handleClick method yet, so our code crashes, of course. That would never happen. Let's see, handleClick is not a function. Well, let's fix that. When we try to click a square, we should get an error. Yep, we definitely did. So we need this handleClick inside of, not inside of the square. Notice. But we need it inside of the board. So now, after the constructor, let's go ahead and create another function called handleClick I. Now all we're going to do is, sorry, I started reading the wrong part. We are going to have a const, same as a var or let, squares equals this dot state dot squares dot slice. Now this slice actually takes an array and so the state dot squares is an array, and slice basically copies it over. So it's different than this .state.squares. And we'll get into the reason why in just a little bit. And we are now, remember right here, slice squares at I equals x. This dot set state squares colon squares. Easy enough, right? No, of course it's not. We have no idea what's going on. Well, let's keep going. After these changes, we're again able to click on the squares to fill them. However, now the state is stored in the board component instead of the individual square component. Well, so let's look at this. Oh, I forgot to save. Save. It refreshes. Look at that, we get x's again. Why do we get x's again? Well, again, we called in here the render square on click handleClick I, and this is right here. So this is a prop that goes over to here, over to the square, and it calls the boards on click, because on click here, this .props.onClick goes to the handleClick I here. So that makes sense. We'll go over it a little more in more detail with some arrows later. Note how in handleClick we call .slice to create a copy of the squares array to modify instead of modifying the existing array. So why? There are generally two approaches to changing data. The first approach is to mutate the data by directly changing the data's values. Okay. The second approach is to replace the data with a new copy which has the desired changes. So without mutation, something like this would happen. So var player score 1, name is Jeff, new player is object.assign player score 2. So the player is unchanged, but new player is score 2 named Jeff. Then results is the same, but by not mutating or changing the underlying data directly, we gain several benefits described below. Complex features become simple. Immutability makes complex features much easier to implement. Later in this tutorial, we will implement a time travel feature that allows us to review the Tic Tac Toe game's history and jump back to previous moves. So detecting changes. This detection requires the mutable object to be compared to previous copies of itself and the entire object tree to be traversed. Detecting changes in immutable objects is considerably easier if the immutable, and immutable means it hasn't been mutated or changed at all, object that is being referenced is different than the previous one, then the object has changed. So, determining when to re-render in React. This is a big one. Main benefit of immutability is that it helps you build pure components in React. Immutable data can easily determine if changes have been made, which helps to determine when a component requires re-rendering. So basically we only want to re-render something if there's been a change. Other than that, we can just leave it the same, right? This immutability principle helps with that. And there's a should component update method that you can learn about if you want to read this optimizing performance. We're not going to get into that. Okay. Functional components. We'll now change the square to be a functional component. It's a simpler way to write components that's only contain a render method and don't have their own state. So a square doesn't really need its own state. All it needs to do is display a value, right? So let's do that. Let's replace the entire square class with the function. So we need that because that's in our class. Go ahead, get rid of everything, return. Remember, open with parentheses. Let's go ahead and end with our semicolon. Now we're going to just return a button. The class name is still square. Forgive my spelling. And onClick equals props.onClick. And we're going to say props.value. Close the button. Seems easy enough, right? So we've changed this .props to props both times it appears. Why is that? So in a functional component, we don't need to worry about this. Now we need to take turns, right? So we got this, should still render. Line 7. Notice this says line 7. Shows button on line on click. So what did we do wrong? Let's go back and look, and we may not have done anything wrong, huh? So class name equals square. Class name equals square. OnClick equals props.onClick. OnClick equals props.onClick. Props.value. Well, we're good. It just isn't going to render for a second. It says unexpected token, so we do need to get rid of that, and I don't know what the unexpected token is. Return, I did spell correctly. Parenthesis, semicolon, we have this closes our class. Again, I could pause and debug this and figure it out, but part of what we're doing is learning how to actually do this correctly. Everybody runs into errors, so that is why I'm not pausing. Props.value. Well, we could try this. Oh, I know what it is. I do know what it is. Guess what we did not change? This class is no longer a class. They just want it as a function. That gets props. So now it is a functional component, okay? So it's still a React component, but it's a functional component. So it's literally just a function that gets us a button with a class name of square. That's all this is now doing. Well, see, we still have it rendering, still have x's, exact same, but look how much nicer that code looks. Whereas if we looked right here, let's keep going back. Look how much code that was. That is 6 through 22. We have 17 lines of code right there. That is 5 lines of code. A little bit cleaner, right? A little bit easier to actually read and get through it. Kind of nice for us. So, if we want to, if you're lost, you can view the full code at this point. This is exactly what they have. If you needed to, you could copy and paste everything. Let's try not to do that though. If you're stuck, go back, see what's missing, because again, you have to learn to do this on your own. You can't just copy and paste every single time. You have to understand what's going on. So, let's continue. Functional components are less tedious to write than classes, and many components can be expressed this way. Okay. View the full code. Don't need this because it's now a function, not a class. We now need to fix an obvious defect. We don't have any O's. Okay, so class board. So here we are in the board. We need a O. We need to say that we have an O. And so X is next is what we're going to call it as a Boolean. So let's go ahead and constructor super props the state squares fill null perfect, but we are doing this right afterwards, comma, X is next. We're saying it's true because we're gonna always start with X, right? Every time a player moves, X is next, a Boolean will be flipped to determine which player goes next, and the game state will be saved. We'll update the board's handle click function to flip the value. Okay, so handle click right here. Handle click. Instead of just saying X right here first, see squares I, we are going to, and let's go ahead and comment this out. Create a new line, squares I equals this dot state, so the state dot X is next. This is what's called a ternary X, so it has a condition just like an if statement, so this is a shortcut of an if else statement. This is a Boolean, so this will evaluate to true or false. If it evaluates to true, it does this very first next, which is separated by a colon. If it does not evaluate to true, it'll do the else part. So it's going to return either X or O, which is exactly what we want. Now, not only that, but what we not done? We have not flipped the value or the Boolean to true or false. So now let's do that. This dot set state, notice set state, we can do the exact same thing as before. So let's go ahead and put this on separate lines. You don't need to, but it does make it a little easier to read. Separate by a colon, or a comma, I'm sorry. A comma. X is next, colon. This dot state dot X is next. Now, this is shorthand. The exclamation mark means not or false, basically. So what happens with a Boolean, if you remember, when we have a true and we say not true, it would become false. If we have a false and we say not false, it becomes true. So this is a very simple shorthand to flip a Boolean. Okay? Not the Boolean it currently is. Because it only has two different options, we just use the not statement and it flips it to the other option. Perfect. So, there we go. X's and O's can take turns. Let's also change the status text in the board's render so that it displays which player has the next turn. Well, where is that at? Remember right here, status, next player X. So, next player plus this dot state dot X is next, question X colon O. Should be good right there. Now, because we're using concatenation, we're putting a space here, that way we have it laid out correctly for what's actually reading. If we didn't put this empty space, it would show it right here. It's not wrong, it's just preference. I think it looks better with the space. Most people would probably agree with me, but you may not. So there we have that. Now let's go ahead and save. What is happening? Let's refresh. Failed to compile. Line 29. Oh, I'm sorry. No semicolon. We can put a comma though. There we have it. Now, next player X. Look at that. Next player O. X. O. Now, if I refresh this, here's the next part. Notice we don't have a winner. We can just keep playing. So, they will tell us that exact same thing right here. After applying these changes, you should have this board component. Okay, yep, we do. Let's look at everything just to make sure. Const squares, squares I. This dot set state, X is next, yep, render should be const, and then all this in the divs. Declaring a winner. Now that we show which player's turn is next, we should also show when the game is won and there are no more turns to take. We can determine a winner by adding this helper function to the end of the file. So when they say end of the file, they mean end of the file. Because right here, notice this is still a React DOM.render game. We can read that in a bit, but we do need that. Function, calculate winner, squares. So we're passing in the array called squares. Now const lines equal array. Remember, end that with a semicolon. 0, 1, 2, comma. Now I'm just going to copy and paste and then change these numbers. You can copy and paste from here. 3, 4, 5, 6, 7, 8. The reason why there's 8 ways to win. So 0, 1, 2, this is the very first row on top. 0, 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, 8. Then we have 0. So let's change those first. 3, 4, 5, 6, 7, 8. Now we have 0, 3, 4, 5, 6. 0, 3, 6. Now it should be 1, 4, 7. Now how did I get those without looking? Well, this starts at 0, next one's 1, and we're going down, so we just add 1. We can do the same thing here. 2, 5, and 8. Add 1, add 1, add 1. Now we have 2 left. Where are they? Well, 0, 1, 2, 3, 4, 8. So we got diagonal 0, 4, 8. And then the other diagonal, which is 2, 4 again, and 6. 0, 1, 2, 3, 4, 5, 6. So there we have it. Let's go back. Now we need to do a for. Introduction of ECMAScript 6, we started using let. So if you want to read up a little bit more on that, lines.length I plus plus, oops, and that's the length of this array. There's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's going to check 8 ways. Now in here we need a const a, comma, b, comma, c. And that equals lines I. And then let's do our if statement, because we need to say if it fits, we win. Squares at a and a triple equals, or is that b, and let's make sure we did that all right, because I feel like I have too many ending. So I'm going to go ahead and maximize this so we can read it a little easier. Squares A, yep, see right there, that should have closed there, which means I have an extra there. And squares A, that should have closed there, it didn't. Equals squares B, and see, this is why you check your code. So what it's saying, if squares A is not null. So this by itself is just saying if it's not null. And squares A is the same, so if it says X, the same as B or O, either way, and A is the same as C. Okay. Let's go ahead and put it back over here. So our if statement is correct at this point. We are going to return squares A. Now, we don't even need to put these on separate lines. Some of this is up to your own coding preferences. If you want to put this here like that, go for it. If not, don't. But there we have it. Return. And then we have that case. Return null. Now, let's look at this a little bit. I'm sure you've gone over some JavaScript by now. If not, definitely go over some JavaScript. But just to clarify how this works, we create these lines, okay? 0, 1, 2, 3, 4, 5, 6, 7, 8, etc., etc. We now assign A, B, C to that specific row. If the row inside of squares itself, which gets passed as an array, notice we're not changing that array, we're just setting up the win conditions. These are the ways that you can win. Okay? And then we're assigning it, did they win this way or did they win this way? Go through, go through, go through. Okay? So when the program looks at it, it says, did it win this way on row 1? Nope. Did it win on row 2? Nope. Row 3? Nope. Row 4? Or in this case, column 1, column 2, column 3. Did it win on the x's? Did it win on the other x's? So did it win on that line? And if, and only if, it won on that line, so if all three squares are the same value, it's going to return. Now this return statement breaks us out of the for loop. So if we went on the very first one, it just breaks us out completely. The entire function is completely over, and we are determined who won. Now what we're passing back is either an X or an O, which is completely fine. We don't need to return true or false. We actually want to pass X or O. If we pass true or false, we wouldn't know which one won. We'd just know that somebody won. In this case, we want to know who won. So we're passing back if it was X that won or O that won. Okay? Now we've written this, we're not calling it. So let's go back over to here. We will call calculate winner squares in the board's render function. So that is on board render right here. So we have the status, and we can do this right before. Actually, we're doing it inside. Notice we're changing this quite a bit now inside this render function, but only this first line. So let's comment it out. Const winner equals calculate winner this dot state dot squares. There's going to be a status. Now if winner, so if we don't return null, status equals winner colon space concatenate plus winner. Else, and it automatically did the lines for me. We'll just keep going with the code like that. Status equals next player colon plus this dot state dot x is next question mark x or O. And there we have it. So now if we win, it'll tell us who the winner was. If we didn't, it'll display next player is. So let's go ahead and try that out one more time. It's always nice to test your code, right? Winner X. Notice I can keep clicking though. So I think we need to stop the game at that point, right? Well, we can now change handle click function because we did this code already to return early by ignoring a click if someone has won the game or if a square is already filled. So now we got to go back to handle click right here. Now const squares, we already did that. If winner squares or squares I return. So what does this do again? So we say if calculate winner, and remember calculate winner is inside of our render function. Sorry, right here calculate winner is this .state.squares. Calculate winner itself down here. Okay, so if calculate winner. And so every time we click, we're going to say if and check it, and we're going to run that function. Oh, and see, that's why we look at our code. I accidentally did curly brackets. We wanted the double pipe for the OR. Here we go. Let's see what happens. Look at that, I can't click anymore. Okay, so we have to now refresh to start over. Well, our game is now done. We can play differently. Winner's still X, O, X, O, X, O. Winner is O. So we know it works. We could check every single way, and if you wanted to truly test this, you would check and test every possibility. But we'll be okay without that. Do notice as well that if I keep clicking on the same square, and you can't really see me click, but I'm clicking on the same square, it doesn't render another, it doesn't switch it to X and O and X and O, it doesn't alternate. Before we put this code in, it would have. So if I commented out this code again, notice I'm clicking and it alternates. Never tested that before, did we? But there we have it. Okay, so we have the entire game over. Good job. It only took us an hour and 15 minutes about. Adding time travel. This is the last part. This just basically shows us a little bit of the extra features of React itself. So let's go ahead and put this in there. We want to store a history of moves. So what we want to do is we actually want to copy the state of the moves, and so we slice it again. We don't want to manipulate it until we have, so we create a copy and set it as that copy. Okay, so this is basically what our history would look like. So how do we do this? Well, we have to lift the state up one more time. So now we need to lift it up to the game. And at this point, the board will mostly become a functional component as well, if I remember correctly. So we need a constructor, pass props, super props, this dot state equals history is an array of object squares colon array 9 dot fill null comma we also need x is next colon start it with true. Let me go ahead and close that. So far so good. Next we'll have the game component receive squares and on-click props from the game component. So we need to delete the constructor and board. Get rid of this completely. Replace this.state.squares I with this.props.squares I. In the render square. So state will switch to props. Replace this.handleClick I with this.props.onClick. And board's render square. Props.onClick I. Hope I already had that part. Okay. So board's component should now look like this. So render square. We have return square value this dot props square I on click this dot props dot on click I check. Now we'll update the game's component's render function to use the most recent history entry to determine and display the game's status. Okay. The reason why we're doing this is so we can go back in time. So in order to do that, we need to go to our render function. Inside of game, I believe it is, the game components render. So here we go. We need to put a const called history, and that equals this.state.history. Current equals history. History.length -1. Const winner equals calculate winner. Current.squares. We have a status. And let's go ahead and copy that from here so I don't have to write it all over again. If winner, status is winner or status equals next player, this dot state dot x is next, etc. Good. Now inside board, which is here, squares equals that is not inside board. My bad. We are still inside game. So we did the return function. Class name game, game board. See, now we have board right here. We're adding into here. So we're going to go ahead and put that on another line. Squares equals current.squares on click equals, remember this is an arrow function, we're passing a parameter, this dot handle click I, and then we close it. Perfect. Div We might have missed a couple instructions while going faster. I don't want to make this too long. Right here's this div. And we'll go ahead and say status right here. Which is this status, if you remember. Since the game component is now rendering the game's status, we can remove the corresponding code from the board's render method. After refactoring, the board's render function looks like this. So now we're into board. This should now render. We don't need this anymore. All we need is a return statement. Inside the return, we'll have a div. Class name is board row. So we even got rid of this. This dot render square 0, 1, 2, board row 3, 4, 5, 6, 7, 8. Perfect. So we just got rid of quite a bit inside the render. Finally, we need to move handle click method from board component. This entire function, we can literally just cut it out into the game component. And we'll put it after render. But see, that's there. Always make sure you know where you're placing your code. Go ahead and copy paste it over there. Not only that, we need to change it a little bit, okay? So anytime we handle a click, we concatenate new history moves onto history. So in order to do that, we need const history equals this dot state dot history. Const current equals history dot length -1, and const squares equals current dot squares dot slice. Remember, so it's immutable. If calculate winner, return squares or squares I. Return squares I equals this dot state x is next x0 xo. This dot set state. Here is where we need to do a little bit different. So again, let's comment this out. We, instead of squares, we now need to say history dot concat. So we add a new array element, squares, squares, comma, then curly bracket, close the array, close with parenthesis, check. And x is next, which we already had, not this dot state dot x is next, comma. So now that we have that all written, notice all we did, we already had this x is next there. But instead of squares here, we changed it to history of the squares. Unlike the array push method, you might be more familiar with the concat method. Doesn't mutate the original array, so we prefer it. Push mutates, concat just does not. So at this point, the board component only needs the render square and render methods. So let's make sure board render Render square, check. The game state and handle click method should be in the game component. And of course we're getting an error on line 96. What is the error? It's because I'm really bad at hitting comma. Okay, new error. Duplicate decoration squares. I did it twice. And that's because I didn't comment one out. So let's go back up. We want current.squares.slice, not this.state.squares. There we go. Now look, it renders again. And we can still win. Unlike the array push method you might be more familiar with, we did that. Showing the past moves since we are recording, and we are almost done, trust me. Just a little bit of more changes. Okay. In JavaScript, arrays have a map method, so this is commonly used for mapping data to other data, for example. Okay, we're okay with that. Let's map over the history in the game's render method. So we're going to go to game, which we're here, render, check. After winner, right here, we're going to say const moves equals history.map arrow function inside of here. And then we're going to say go to move number plus move colon go to game start. So basically it's showing, and we're not done yet, just FYI. But this is saying the move, if it is there, we say go to move number whatever the move is. Else there's just one that says go to game start. We haven't displayed this yet. So before we finish our function, go to game start right here, we need to say return parenthesis a list item. This is HTML. Button on click equals a function, which is another arrow function. This dot jump to move. DSC. Close the button. Close the LI. Now, I don't know why they had extra space here. We don't really need it. But I would tab that over so it's a little more readable. So we did the return. LI. And then we have bracket, parenthesis, right there, which closes the map. Okay. This literally closes. This is all one function from map. And then OL right here. Moves. because that will actually display our moves now. Will it work? Hopefully. Look at that. Now, will it actually go anywhere? No? Why? Well, jump to is not a function. We haven't written it yet. When we render a list, React stores some information about each rendered list item. When we update a list, React needs to determine what has changed. We could have added, removed, rearranged, or updated the list's items. Imagine transitioning from 7 and 5 to 9, 8, 5. And from our perspective, it swapped certain things, but computer-wise, it's a little different. So you can go ahead and read through that. Okay, now it's the sequential number of the move. The moves are never reordered, deleted, or inserted in the middle, so it's safe to use the move index as a key. In the game components render method, we can add the key as li key equals move. React's warning about keys should disappear. Did we see a warning? Each child in an array or iterator should have a unique key prop. So we'll do exactly like they say, return li and that should get rid of our warning, right? There we have it, no more warning. If you need to, they have these view the full code at this point. Okay, now clicking any of the list items buttons throws an error because the jump to method is undefined. Before we implement jump to, we'll add step number to the game component state to indicate which step we're currently viewing. So, very first thing, up in the constructor, right before x is true, we're going to add step. Oops, sorry. 0, because we start on 0. Next, we'll define jump to method in game to update the step number. So we need, they're doing it right after handle click, so we'll do it same place just so we don't get confused. Jump to step this dot set state step number colon comma x is next step 2 comma. So why did we change this? Well, it's a true or false, right? The percent sign, and you may have ran across it or not, is modular. So what this means is step number is literally a number. So it starts at 0 and adds up each time from there. Or it basically puts us on whichever step we're on. Now the problem with this is we could be on X and we go back to a step that's on O. We could go back to a step that's on X. We really just don't know. And we shouldn't necessarily have to care, but we do need the step number. So if it's an even number, so mod 2, so if there's no return value, or no leftover of any number at all, then it returns true. If not, it returns false. Does that make sense? Okay. Now we need to change the handle click. So let's go to handle click. Const history. This state history slice 0. This state step number plus 1. current should be fine. So should squares. Now we just need to go into the set state here. Step number colon history.length, comma. Finally, we will modify the game component's render method from always rendering the last move to rendering the currently selected move according to step number. Whew, almost done, guys. So here we are, render history and then current. Instead of history and then the history length, we need to switch this to this dot state dot step number. If we click on any step in the game history, the Tic Tac Toe board should immediately update to show what the board looked like after that step occurred. Let's see what happens at this point. Go to game start. Cool. Look at that, we're adding buttons. Well, what if I want to go back to move 2, move 4? Now, there is a little bit of a nice feature if we do this. Let's say we go back to move 1. I move up here. Look at that. I'm like, okay, well, they just won. I don't really like that. We can go here. Nah. And start the game over from just that specific state, whichever state we want. So kind of cool, right? So wrapping up. Congratulations, you've created a tic-tac-toe game that lets you play a tic-tac-toe, indicates when a player has won the game, stores a game's history as the game progresses, and allows players to review a game's history and see previous versions of a game's board. Check out the final results here. So if you want or have extra time to practice, they have some extra ideas. Display the location for each move in the format call, comma, row in the move history list. Bold the currently selected item in the move list. Rewrite board to use 2 loops to make the squares instead of hard coding them. So it'd be a double for loop. Add a toggle button that lets you sort the moves in either ascending or descending order. When someone wins, highlight the 3 squares that caused the win. When no one wins, display a message about the result being a draw. Kind of cool, right? I don't think it's too bad. We could definitely do it if we wanted to. But since this has been long enough now, let's just go ahead. What I'm going to do, we're going to print my screen. Go over to Paint. And hopefully I have the right part of the code. Yeah, that is a little too long for that. So square and board we don't need to worry about. Board just literally renders it. Don't really need these anymore, but they are still there. Extends React component, constructor props, super props, and we might need them. I think they might actually use, they do use which array item it is, so we do still need these 0 through 8. Okay, here we go. Constructor, history, step number X is next. When we render it, const moves, we map the moves so that we can actually display them as a list item for a button so we can jump to a specific move. If there's a winner, display the winner. If not, say who's next. And then we return all of this, which is the game board. The board has squares, and on click, and that's literally all we're doing right there. handle click, jump to. So I guess you could say kind of interesting, but it does say squares is current.squares. Inside of here, history. And that's inside the board itself. So we do call this board class, giving it this and that. And this fills values of the board class, these square values right here with the props. And there you have it in a nutshell. If you have any questions, need a little bit further of an explanation, go ahead and ask away. And I will see you next time, where we're actually going to start building our own web page now. We designed it a little bit, decided what we wanted last time, so now that we've gotten a little bit more familiarity with React in a nutshell, we'll go ahead and build our user interface and start doing that next time.